This rational function is written as a transformation of parent function. It differs from parent function because it's shifted to the right 3 and up 2. Yesterday, when you graphed these transformations, you would look at the denominator to get the vertical asymptote of x equal 3, and you would look at this number to get the horizontal asymptote of y equal 2. We want to do this a different way. We want to look at our rational functions as a single fraction because it makes a lot of the other things we have to find, like x-intercepts and y-intercepts, a little bit easier. And in the future, holes in the graphs and slant asymptotes. So we're going to combine these fractions. Let me drag that work out here so you can see it. I took 1 over x minus 3 plus 2. I'm creating a common denominator, and I get 2x minus 5 over x minus 3. So that's the function we're going to look at now. And I'm going to refer back to this chart. How do I graph? Well, starting today, the first thing we'll look for is the vertical asymptote. How do I get the vertical asymptote? I look at this denominator, x minus 3. I set it equal to 0, and I get the vertical asymptote. Getting the horizontal asymptote is different, but just as easy. I would divide. Look back at that checklist. I would divide, find the horizontal asymptote, divide the numerator by the denominator. So when I come back over here and I want to divide numerator by denominator, 2x minus 5 divided by x minus 3, I just look at these first terms. 2x divided by x is y equal 2. Each time I switch pages, things disappear again. Okay, so let's graph those asymptotes. X equals 3, y equals 2. Couple of things we can also do, looking back at that chart, we can always find an x-intercept or a 0 by setting the numerator equal to 0. So I'm going to look at that numerator, 2x minus 5, set it equal to 0, solve for x. That's going to be an x-intercept or a 0. I can always plug in a 0 for x to get a y-intercept. So if I plugged in a 0 right here, that would become 0, that would become 0, and I'd be left with negative 5 over negative 3, which is 5/3. That's our y-intercept. Those points are on our graph. And I'm working with my screen, so hopefully I can do this okay. 5/2 is the same as 2.5. So right about here, I'd put a point, and 0 5/3, that's 1 2/3. Well, my parent function would have gone through these points. And the other branch would be up here, which we could get by plugging in some values. I could have plugged in a 1, 2, 3, 4. If I plug in a 4, that's supposed to say f of 4, and I'm plugging in a 4 up here. 2 times 4 is 8, 8 minus 5 is 3, and 4 minus 3 is 1. So you can see I have the ordered pair 4, comma 3. And we've graphed our function. From the asymptotes, we can always name the domain and range, just as we were doing yesterday.
Rational function cannot be factored or simplified or anything like that, so we're going to just start to graph. To find a vertical asymptote, set the denominator equal to 0. That's your vertical asymptote. To get the horizontal asymptote, divide numerator by denominator. 2x divided by x is 2. The remainder doesn't matter. I don't even have to finish that division. Y-intercepts occur where x is 0, so plug in a 0. X-intercepts occur where the numerator is equal to 0. If we'd like to find some additional points, we could certainly plug in maybe a -2 and a +4. I didn't really pick those points very randomly, but I have some experience about this function. So I'd plug in a -2 and end up with -5 divided by 1. And if I plugged in a 4, 8 minus 1 is 7, divided by 7 is 1. And that finishes off my graph. On the right, I have to finish off my graph on the left. So I'm going to plug in some other values, maybe -4 and a -6. -4 gives me -9 divided by -1. Ooh, that goes way off my graph. Way up here, approximately. And -6 gives me -13 divided by -3, which is a positive a little bit more than 4. That's good enough for graphing purposes. We can fill in the domain and range based on the asymptotes. Domain -infinity to the vertical asymptote, and then vertical asymptote to infinity. Range -infinity to the horizontal asymptote, and then the horizontal asymptote to infinity. If we were to do the long division that's suggested right here, it's not necessary. But if I were to finish the long division, 2x divided by x is 2, then you distribute, then you subtract. We could rewrite this function as -7 over x plus 3, that was the remainder, over the divisor, plus 2. And then it's in transformational form. Notice that the vertical asymptote is still x equals -3. The horizontal asymptote is y equal 2. The -7 in the numerator is what has made the graph so far away from the corners of the asymptotes. So that's another way you could graph using the skills from our previous lesson. Has 2 factors in the denominator, which means we have two vertical asymptotes. Set x plus 3 equal to 0, and set x minus 1 equal to 0. Those are the vertical asymptotes. To get the horizontal asymptote, imagine dividing 1 divided by x squared. If we were to multiply this together, we'd get a trinomial x squared plus 2x minus 3. So 1 divided by x squared can't be divided. So automatically, by default, our horizontal asymptote is y equals 0. Another way to say that is the numerator had a smaller degree than the denominator. So automatically, the horizontal asymptote is y equals 0. Next, we can get some little points. There are no x-intercepts because the numerator is a constant. Y-intercepts, we plug in a 0 and get 1 over negative 3, so negative 1/3. And we'll have to pick some points. We have two vertical asymptotes though, so I'm going to have to pick a point to the right of x equals 1. Plug that in. I'd end up with 1 over 5 times 1, 1/5. I don't need any more points. I can tell what's going to happen there because I know what impact the asymptotes have on the graph. In the middle section, let me plug in a negative 2, maybe a negative 1 if you want. 1 over, plugging in a negative 2 gives me negative 1/3. Plugging in a negative 1 gives me a negative 1/4. Difficult to graph the differences between those. I have plenty of information to know that we have that section of graph. And last point that I'm going to plug in is to the left of x equals negative 3. Plugging in a negative 4, I get 1/5. You're noticing some symmetry. Quite often, there will be symmetry in these rational function graphs. The domain is affected by two vertical asymptotes. Moving too quickly there. And the range is affected by one horizontal asymptote. The middle section of a graph like this can turn out differently. So all graphs with two vertical asymptotes do not look like this one. Pay attention as you're doing the practice questions.